solve for x. And here we have the equation, the natural log of 5 plus the natural log of x minus 8 equals the natural log of x. So in order to solve for x here, we need to remove the logarithms, right? Because we can see that x is trapped within the arguments of these logarithms. So how are we going to do that? Well, we want to apply the inverse property to remove the natural logarithm, but we can't do that right away because we have the sum of two logarithms on the left-hand side. So how can we combine those? Well, we want to apply those algebraic properties of logarithms. Remember that if we have, say, the natural log of a plus the natural log of b, we can combine those two logarithms by the product property and rewrite this as the natural log of a times the natural log of b. So that's where we are going to begin. We can rewrite this given logarithmic expression by applying this algebraic property and say that we now have the natural log of 5 multiplied by x minus 8 is equal to the natural log of x. Beautiful! And let's actually simplify this a tiny bit further. We can take this 5 and distribute it through to both terms on our left-hand side. And now rewrite this as the natural log of 5x minus 40 is equal to the natural logarithm of x. So, now that we have one single logarithm on the left and one single logarithm on the right, we can apply that inverse property. So we are going to apply the natural exponential to both sides of this equation to remove the natural logarithm. So we apply the natural exponential to both sides. So this will become the natural exponential raised to the natural logarithm of 5x minus 40 is equal to the natural exponential raised to the natural log of x. And now because the natural exponential and the natural logarithm are inverses of each other, they undo the effects of each other, leaving us with 5x minus 40 is equal to x. Beautiful! And so now we are left with a much more familiar looking algebraic expression, and we're ready to solve for x. So in order to solve for x, we need to isolate the x terms. So we'll bring all of our variables to the left and all the constants to the right. So I'm going to begin by subtracting x from both sides of the equation. And let's also go ahead and we'll add our constant 40 to both sides of the equation. So we can see that x minus x on the right-hand side will cancel itself out to 0, and that minus 40 plus 40 on the left-hand side will also cancel itself out to 0. So we have 5x minus x leaves us with 4x, and this is equal to 40. Beautiful! So now I have 4x equals 40. And so to isolate that x, we are going to divide both sides of this equation by 4. So 4 divided by 4 cancels itself out to 1, leaving us with x is equal to 10. And this is our beautiful final answer. Now, just for fun, because math is fun, let's make sure that this is in fact the correct final answer. Now, how can we do this? Well, we can double check our work by substituting our potential solution here into the original expression. So what I'm going to do is use our simplified original expression, written as the natural log of 5x minus 40 is equal to the natural log of x. And now we want to check that this is in fact going to hold true if x is 10. So let's find out. If we let x be equal to 10, what happens? Well, we now have the natural log of 5 times 10 minus 40. And we want to know, is this really equal to the natural log of 10? I don't know, let's find out. So we only need to worry about the left-hand side now. We have the natural log of 5 times 10 is 50 minus 40. And we're getting excited because we know that 50 minus 40 leaves us with 10. Woohoo! So we have confirmed that, yes, this is truly that beautiful final answer.